Hello, my name is Rebecca Holman. I'm here to talk to you today about whale shark movement trends in response to remotely sensed sea surface temperature and ocean productivity, and then its implications for current protected areas and current conservation policies. I'm doing all of my case study in Google Earth Engine, so I have my screen recording for the code that I'm writing in Google Earth Engine to do a step-by-step walkthrough of this case study. So firstly, we're going to look at a couple different data sets in this case study, one of them being sea surface temperature. That is from a GCOM satellite. That's a remotely sensed data set. The second data set we're looking at is chlorophyll A concentrations, and that is a indicator of ocean productivity. Again, that is a remotely sensed data set from a GCOM satellite. Thirdly, we're looking at whale shark GPS, like tracking location data, and that is remotely sensed GIS data from satellite tags in whale shark fins. And then lastly, we are looking at current marine protected areas, and that'll be a map layer in Google Earth Engine. So let's go ahead and get started. So in the case study, it's going to have you create a Google Earth Engine account, and then I give code and that you're going to copy and paste into Google Earth Engine and then try to understand and interpret what is going on. So the first thing that you're going to copy and paste is referencing the sea surface temperature data sets. The first one is going to be filtered by winter data only, and that'll be from October to March. And then you're going to copy that exact same code and filter it by summer data. So let's go ahead and run the winter sea surface temperature data. And I'm actually going to have you add one other thing before that, which is setting a center point that this will use, because we're focusing on the Gulf of Mexico. So that sets a center point for the middle of the Gulf of Mexico. We don't need to look at the whole world. And here we have running right now is our winter sea surface temperature. So you can see that blue is cold from 0 degrees to 30 degrees Celsius, with dark blue being the coldest and red being the hottest. So in the winter, the Gulf of Mexico is in between green to medium orange. Now, next I am going to have you run this exact same code, but we are going to do summer data. So essentially what the code that you're writing is you're referencing this data set that already exists within a catalog on Google Earth Engine, and this is its name here, which is sea surface temperature, which is from this satellite, the GCOM satellite. We're filtering it by date here so that we are only pulling summer dates. And then you're also filtering it by a satellite direction. So this is only daytime satellite information. You do some other stuff to change the visibility, make it look better. And then you're adding a map layer down here. You add the layer. So let's run this. Sorry, running each of these takes a few moments. It's a lot of information. So now you can see, you come over to this layer box over here, and since we named them all, we can see that this is sea surface temperature in the summer, sea surface temperature in the winter. So this is the summer data that we're seeing now. The Gulf of Mexico is much deeper orange to almost red. It's a lot hotter in the summertime. You can see that reflected here. Now we can toggle back into the winter data, and now you can see the difference between the two. Okay, now we're going to add some information about chlorophyll A. This is a Chlorophyll A is an indicator to reference ocean productivity. Come on. There we go. So this is just coming from another data set that exists in Google Earth Engine Catalog, which is a data set about chlorophyll A. Anything that has a high chlorophyll A level is going to have high levels of plankton and therefore also high levels of other types of marine life. So it's a good indicator for where marine species aggregate. So we are going to add right now our winter layer for chlorophyll A. And while it's running, I'm going to get the code to add for our summer as well. All right, so now we're gonna have 4 layers over here. It's running still, so give it a moment. But as you can see, now we're looking at this chlorophyll A concentration map layers, and things are a lot more blue. So here in chlorophyll A, it's given in a value of milligrams per meter cubed. That dark blue is really, really low levels of chlorophyll A, so that's like more open ocean. There's less nutrients, there's less plankton, there's less animal life. And then as you get higher and higher levels, it goes from green to orange to red. So red being the really, really high values. So you can see like coastal waters have really, really high values of red. That's because there is lots of animal life that live in coastal waters. So right now let's take off our sea surface temperature. And now we're just gonna kind of look at the difference between winter and summer. As you can see, there's not a ton of difference between winter and summer. Red and orange and green are still mostly in the exact same places. The major difference you're gonna see is in the winter, there is higher levels of chlorophyll in more open oceans. And again, you kind of need to think about the fact that we're looking in the Gulf of Mexico and Central America, and winter in these areas isn't necessarily cold. Winter actually is more dry season, and the temperatures are actually more moderate. The summer is the rainy season. So when we're thinking about this data, which is mostly focused on Central America and Mexico, you can't really think in terms of winter and summer. You want to maybe think more in terms of dry and rainy seasons. So now after we have added our chlorophyll and temperature data, we are going to add one more map layer from a current existing data set, and this is world protected areas. So here we're referencing this data set that already exists called world protected areas. It's a polygon data, so it's going to give mapped areas as polygons, and we are going to add this layer. So this layer is giving us current existing protected areas like by law for every country in the world. Again, we're focused on the Gulf of Mexico, so it's mostly United States and Mexico and a little bit of Cuba. And this map layer, if it loads, this one takes a little bit because there's a lot of information. And it's actually easier to see over the sea surface temperature. Actually, we'll just do it with no other map data. It's still going. It's not totally done, but you can see these light green areas are the protected areas. And when you look in the Gulf of Mexico, there's not a ton. Still adding a few, but for the most part, there's not much going on here. There's some protected areas down here off of the eastern Yucatan Peninsula. There's some around the Florida Keys. That's good. There are a little bit, like some little coastal areas. But for the most part, this giant open ocean in the Gulf of Mexico has no protected areas. That's just useful to think about. We're going to use this information more once we add in our whale shark data. So for our whale shark data, we're actually going to import our own data set. I was able to find existing GPS data from a paper that was published in 2014. That data is freely available on MoveBank for people to download, and it's as a CSV file. So we're going to have to turn that CSV file into a data set that we can use in Google Earth Engine. So you're going to come over here to this box. You're going to click Assets. We are going to click New Table Uploads CSV File. And then you're going to click Select for your source file. This is right here. It's named whalesharkdata.csv. That is given to you in the module along with this case study document. So that's provided to you. So click this here. Let's name it too. I have already done this a million times, so I already have it in my data, but you could name it. I would just leave it named whale shark data. And then you're going to come down here to these advanced options. Let's actually open. I'm actually going to bring my Excel file over here for you to see for a second. Okay, so this is the CSV file that we're working with right now. These are our column names. So this one is the one that I want to focus on. This is called your individual local identifier. This is a number that's given to every individual whale shark. So 45101 is one individual whale shark. So all of this data right here up to this point is all one whale shark. Then 77007 is another whale shark, and so on and so on. So these are unique identifiers for every whale shark. And then within every whale shark, it has a unique event ID, and that's every time the satellite tag relays an event to the satellite. It gives it a unique ID, the date that it was taken, and the latitude and longitude points that was taken at. So when you are uploading this CSV to Google Earth Engine, you have to tell Google Earth Engine what the column names are for the longitude and latitude, which we have named here location long with a capital L and location lat with a capital L. So when we're uploading this, we have to scroll down to advanced options, and here you say X column longitude. You want to name it the name of the column that we have our longitude data in, which is location long. And then same with lat, that's going to be location lat. That just helps Google Earth Engine reference the right columns. So now we can upload. If you go over here, now our little tasks button is orange because it's uploading. You'll see this little gear turning while it's uploading. If you have decent internet speed, it should take maybe a minute. If you have really slow speed, it might take a little bit longer. For the sake of this presentation, because I already have that data in my Google Earth Engine asset folder, I'm not going to wait for this one to upload. But if you're doing the case study, you have to wait for it to upload. Once it's finished, I would suggest hitting refresh over here, and then you'll see it listed here as whale shark data. Since I already have it here, it's already here. So once it's uploaded under your name, you'll see whale shark data. You're going to have to hit this little right arrow, which imports that data into your coding box. So now it'll pop up over here, which says imports one entry. The variable, it's named table. You could change that name. I suggest not changing it because I reference this in the code that I give you as table. But so this is that CSV file we just uploaded. So just to know that's there, it's called table. So now we're going to add some more code to visualize that GPS data we just uploaded. So right now I am adding code. This it looks like a lot, but pretty much we are making variable names for remember those whale shark numbers that were the unique identifiers? We're going to make each whale shark, its GPS data, show up as a different color. So we're referencing that identifier number here. We're going to tell it to add a layer as a certain color and give it a name. So let's run this. As you can see over here, there's a ton more data now because now we have all of these different whale sharks have different map layers. And as it loads, I'm actually going to just take off these other map layers so that we can see the whale shark data clearer. So each color is a different whale shark. So you can see, you can toggle back and forth between every individual whale shark. So this is number 128779. Here we've got a different whale shark. Here we've got a different whale shark. Here we've got a different whale shark. You know, you can go through and see all of these. If you really are like handy and good with code, you could go through and change these colors. These are just hex numbers. If you don't like the colors I chose, I just had to make up a lot of colors because we're doing a lot of different things here. But if for some reason you want to visualize it differently, you can feel free to play around with that. But essentially, now you can see pretty much where each whale shark is aggregating. And if you look at it as a whole, you can try to see some trends between all of these whale sharks together. And then, you know, you can compare it to, well, later on, part of the questions, we're going to compare it to some of these other things and try to find visual trends between them. But for right now, I just wanted to show you how to import the code to upload all of this whale shark data here. So next, we're actually going to take one individual whale shark, which we're going to focus on this one right here called 45101, and we're going to give a color, each individual date a different color so we can visualize the movement of one whale shark over time. So this, we just wanted to visualize the differences in individual whale sharks. Now we're going to take one whale shark and do the differences in dates over time. So I would suggest adding a line of code here to block out all of this data because we don't need to run it all a billion times. That just makes Google Earth Engine go really slow. So I would suggest blocking that out. I tell you in the case study module how to do that. You can just see what I did right there. It greens it out, which means you don't delete it, but it's not going to run it any longer until you delete those little asterisks. But instead, we are going to now focus on one individual whale shark here. So this is referencing again that in whale shark 45101, but now we are filtering by dates. So we can see here it goes from July, so July 10th through October 17th. And each different date's going to be a different color. So let's run this. I don't like how that looks. I'm hiding that, sorry. And now when you look over at our layers data, you can see those layers for all the different whale sharks are gone because I blocked them out. And now you see the same whale shark, but different dates. And let's maybe take off this so we can visualize those dates better. Okay, so now you can see in real time as the dates are being added, you can see the trending kind of from west to east, hovering around the coast of Louisiana and Alabama. And then all of a sudden, in the middle of September, they drastically start moving south. They go to the tip of Mexico to Cancun, and then they move over to the western tip of Cuba. So again, you can change these colors if you want. I was just trying to make some sort of palette that you could follow. And again, You can toggle, take off certain dates, add certain dates, only look at a few, only look at October. So you can play around with these to just see exactly what we're looking at. So let's see, these 5 down here, these white and gray ones are October. So now the fun part is trying to find trends. So let's put all of these back on. And we are going to put on, let's start with sea surface temperature. We'll do summer. I like to point out here that when we added our summer code, I know that I'm not making you guys write this code, so you might not know exactly what we're doing. But when we're adding the summer code, which is right here, we're filtering it by summer dates only, which is from April 1st to September 30th is what I considered summer. So the whale shark data we have is from July to October. So you have to remember that those October dates are falling out of this range, and so you might want to look at the winter temperature and chlorophyll map layers when you're looking at those dates. So right now, because we have summer data, I'm actually going to take out anything after September 30th. So when you do that, you can see that all of these points are kind of aggregated, and they don't move much in terms of latitude. You know, they go back and forth. I'm pretty sure this is your earliest date, and it's kind of trending like this. So all of that temperature data, I would say, is about the same. They seem to all be in that medium to deep orange. And then if we inverse this, let's stick these all back on and then add our winter data. So now when we're looking at winter, let's take off our September and August and July. Okay, well now we're looking at our winter data. Seems like this whale shark no longer wants to be in this spot because this temperature value has changed drastically. It's gone from almost red to yellow, which is a pretty big swing. I know we don't have exact values here we're working with. So it seems like as the weather changed, as the temperature of the ocean changes, this whale shark wants to stay in that medium orange, and is migrating south to the tip of Mexico here in the Yucatan and the tip of Cuba to stay in that medium orange range. Then let's investigate now a little bit about our chlorophyll. So if we take off our temperature, now we're adding our chlorophyll data back. Let's put all of our points back. Okay, here's with all of our points back. You can see that regardless of summer or winter, it seems that the best place that this whale shark wants to be is kind of in this fringe of light blue to dark blue. They don't ever seem to get too into the green or the orange or the red, and they kind of hover along this light blue section. And so remember again that this data here, we're looking at this red chlorophyll level. That's really, really high chlorophyll levels. That's really, really high plankton levels. And whale sharks feed directly on plankton, phytoplankton. So these are areas that are going to have a ton of plankton, a ton of food source, probably areas where whale sharks aggregate to feed. The problem is that you get too close into these coastal areas and you have a lot of boat traffic, you have a lot of human interaction, you have a lot of shallow waters, you have other things like that that may keep the whale sharks from getting too close to the coastal waters, and probably why there's this happy medium, this kind of fringe light blue area. Also, best temperatures as well. So it's a combination of temperature and chlorophyll A levels that are kind of creating these sweet spots for whale shark movement. And it could be nice to look at some trends for all the whale sharks. So maybe we'll go back and we'll block out this individual level whale shark and take these back off. And let's maybe look at the trends of all of these whale sharks, just general trends in terms of chlorophyll, because I'm curious. I don't ask you guys to do this in the module, but I would like to see, let's do summer. I would like to see if I'm right about this being the best area that they kind of want to hang out in. Yeah, I would say that one's pretty much in that same kind of light blue, not quite open ocean zone. That one, this guy, whatever he's doing, he's going out in the open ocean. I respect that. Yeah, so it's kind of fun to try to interpret all of this. Again, I don't have these blocked out by date, so I can't tell a ton of information because we don't know which dots for each whale shark are which date. You could do that. For the sake of this case study, we're not going to go too far into it. But while we're here, let's I do have you for the case study, bring back all of these whale shark data and then compare that to the world protected polygon data. It's going to take a second to load that. That layer always takes quite a bit of time, so let's have that load. And now I ask you in the case study to kind of think about the trends of that whale shark 45101, how it moves relative to temperature, how it moved relative to chlorophyll, and then to think about the trends of all of these whale sharks and their patterns within the Gulf of Mexico, and try to think of what could be causing their movement and why. And then the last thing I have you do is think about the existing marine protected areas. They have terrestrial as well on this map layer, but because we're thinking about whale sharks, it's really more marine protected areas. And their potential efficiency. So it looks like this one is loaded now. So again, you're looking at this light green as protected areas, and then you're looking at the whale shark data, and pretty much not a single spot that a whale shark is in this data is in a protected area. So that's kind of a cause for concern, as whale sharks are very endangered species, and we don't really know a ton of information about them and their behavior and why they move and patterns that they move and why they feed where they feed and why they aggregate where they aggregate. So this is kind of an interesting take to try to think about how we can learn more about whale shark behavior and movement through remotely sensed data, because it can be quite expensive and mostly cost prohibitive, but also time prohibitive. They're hard to follow. It's hard to do actual tracking of whale sharks in the ocean, in a boat. And so if we can get GIS satellite data from whale sharks and use that in conjunction with remotely sensed sea surface temperature, chlorophyll levels, other potential indicators I feel like there's a lot of stuff that we can learn about whale shark behavior through just remotely sensed data and virtual manipulation of data. And one of the things that I think is maybe the most important thing of this case study is pointing out how the lack of protection that whale sharks have. Again, this is specifically isolated to the Gulf of Mexico. Whale sharks have a global distribution. It would be interesting to try to find global whale shark data and look at that relative to this global map of protected areas. But yeah, there's not much that is protecting them in the Gulf of Mexico, and two of the main reasons why whale sharks are endangered is because of bycatch, like unsustainable fishing practices. It seems weird that whale sharks would be bycatch because they're so large, but they are. And again, and the second thing that actually causes the most whale shark deaths is boat strikes. So in marine protected areas, you have at least restricted fishing, if not total fishing bans. And so in protected areas, you have less boat traffic, you have less fishing, you have more sustainable fisheries. If there is fishing, it's much more regulated. And all of that could do a ton to conserving whale sharks. And so I think that this module, this case study, kind of highlights a lot about what is lacking in terms of protected areas, but it also shows about how useful Google Earth Engine and remotely sensed satellite data can be for learning more about whale shark behavior and ecology. And it also helps give an introduction to coding in Google Earth Engine, which is like a very, very useful tool. I have never used Google Earth Engine before I did this project, and I was able to figure out a lot of code intuitively. So it would be, if you are interested beyond what is asked in this case study, you can take this code and play around with it, and take that CSV file and play around with it and try to manipulate it in other ways. But yeah, that's the end. Thank you for listening to this presentation. And if you have any questions about this project or about this data or where I got it from or how I came up with this code, feel free to message me. I would be glad to talk about it at any point. Thank you so much.